recording. Okay. So one more time, the 5 key points are -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. And those are the 5 key points for the parent function, f of x equals x cubed. And then yesterday I told you guys that those 5 key points came from plugging it into the function. So if you take the -2, -1, 0, 1, 2, and plug it into the x cubed, that's how you get the y values, okay? So you're always going to graph those 5 key points in our function, the parent function, and we're going to label it f of x, okay? And then we look at the transformations. The transformations told us A, I don't really do anything with A, but my H, I'm going to take every point and I'm going to move it to the right 3, and the same point, move it up 1, okay? So I'm going to take every point, we're going to move every point to the right 3 and up 1, okay? Take every single point, you're going to move it to the right 3 times and then up 1, okay? So for example, down here at the -2, -8, I'm going to move it to the right 3 times, so 1, 2, 3, and then I'm going to move it up 1 time. So my coordinate point is going to end up right here at +1, -7, okay? So one more time, take the point, move it to the right 3 times, and then up 1, okay? So I'm going to do the same thing with -1, -1. I'm going to move it to the right 3 times, 1, 2, 3, and then I'm going to move it up 1 time. So I end up at 2, 0. And then we're going to keep doing that. You don't have to put the little loops. I'm just trying to show you where that's coming from, why I end up where I end up, okay? So then 0, 0, move it to the right 3 times. So 1, 2, 3, and up once. And then your 1, 1, same thing. Move it to the right 3 times and up once. And then your last coordinate point, I don't know if you guys can see that, so I'll zoom in a little bit. So then my next point right here, this one, I'm going to move it to the right 3 times and then up once. So I end up at like 5, 9. 1, 2, 3, up once. And then once you have your 5 points graphed, then you're going to connect the curve again. So starting at the bottom, shift it a little bit more to the left. Go upwards and then end a little bit further to the right of the graph. And then the green one is g of x. So let me label f of x on the other side. Okay, and you want to make sure you label which one's f of x, which one's g of x, because you need to know which one was the parent function, which one was the transformed function, okay? So if you have like a different colored highlighter or something, or if you have a colored pen, you can highlight the g of x so that you know which one was like your final transformed function. Okay? And then that's basically what you're going to do. You're always going to graph the 5 key points, and then you're going to move based on the translations that we found yesterday. I don't know. I still see like very few of you still writing. All right, let's move on to the next example. All right, so this is on the second example. So this is at the bottom of the page, correct? Double check that your equation is the same. You should have the x plus 2 to the third power minus 3. Double check you're on the right example from yesterday. So again, yesterday we saw that A was 1, which means no stretch, compression, or reflection. H, don't forget we switched the sign. H was positive, so it became negative, which told us we go left 2. And then K was negative 3, which means we go down 3. Okay, that's what we did yesterday. So for today, we're graphing. Remember, you got to graph the original function. The 5 key points are always the same, okay? The 5 key points are always going to be negative 2, negative 8, negative 1, negative 1, 0, 0, 1, 1, and 2, 8. Those are always going to be the same 5 points, okay? So let's go graph it. We're going to go left 2, down 8, left 1, down 1, 0, 0, and then right 1, up 1, and right 2, up 8. That black one is always going to be the same. Question?
So, f of x will always be that same line?
Yes, because we're transforming the parent function x to the third power. Sorry, I couldn't get the bottom. So remember, starting a little bit farther from the to the left, and then you should end up a little bit shifted to the right. And we're going to call that one f of x every time, because that's the parent function. We are transforming the parent function, which is f of x equals x cubed. And then we are going to be looking at this information over here. What are we going to do to every point? We're going to move every point, left 2 and down 3. Okay? So I'm going to take that negative 2, negative 8, but this time I'm going to go to the left 2 times and then down 3. Okay? So go left 1, 2, down 1, 2, 3. Okay? So negative 2, negative 8, I'm going to go left 2, down 1, 2, 3. You should end up at like negative 4, negative 11. And I'm not sure if you guys can see that again, so let me zoom in so you can see it better. Okay, then the next one, take that negative 1, negative 1. You're going to go to the left 2 times and then down 1, 2, 3. Okay? So left 2, down 1, 2, 3. And then do the same thing with 0, 0. Go left 2, down 3. And 1, 1, you go left 2, down 3. You should be at like negative 1, negative 2 on that one. And then the last one, you were going to go left 2, down 3. And then you're going to connect the two, you're going to connect all 5 points together. We're going to go curve it like this. Okay? And then you're going to label the second one as g of x. And then that's it. We finished graphing. Okay? Today's going to be more of the simpler versions. We're only going to be looking at translations, moving like left and right, up and down, and that's all we're going to do today. Okay? All right, so now move on to the next page and go find this example. Did we not do this one? X plus 1 cubed plus 4?
That's the next page.
Yeah, right? It's the one at the top?
Yeah.
It's the one at the top, right? I don't know why I didn't have the A, H, and K, but A, H, and K information was right here. A value was 1, is out front. A value is 1. That means there's no stretch, compression, or reflection. Our H value was a negative 1. You got to switch the sign. And then that tells you go to the left because it's negative. And then for the K value was at the end, that plus 4. That told us K was 4, so we had to move it up 4. So you guys are going to try this one. You're only going to move every point. You got to move every point left 1 and up 4. And it's the same 5 key points. That black function f of x is always the same. You always take the same 5 key points, okay? -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. So go ahead and try this one. You're going to graph the original f of x and then move every point to the left 1 and up 4. You guys can double check your work. Here's the transformed function. We have the parent function right here, f of x. Quiet, please. Double check your graph. The black one should always be the same for f of x is the parent function. And then g of x is the green one. All I did was took every point and I moved it to the left 1 and up 4. So left 1, up 4, left 1, up 4, and so forth. Okay? And make sure you label which one's f of x, which one is g of x. All right, next one. Make sure you go find the correct equation. This one is a x cubed minus 2. So you should have this on your notes. Some of you put them in different places, but this is a x cubed minus 2. Go find this one that we did yesterday. A was 1, so we had no stretch, compression, or reflection. Our h value, remember, why was h 0 in this example? Below? Nothing here for h. It has to be between the x and the cube. There's nothing there, so that means there's no horizontal shift. We're not going to move it left or right. All we're going to do is look at k, and k is -2. So all we're going to do in this example is move every point down 2. And that's all we're going to do. So take your parent function, go graph it. Your 5 points are the same every time. -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. And make sure to connect those together. And we're going to label that one f of x. And just take every single point and you're going to move it down 2 times. So just down 1, 2. -1, -1. I'm going to move it down 2 times. 0, 0. Move it down 2 times. 1, 1. Move it down 2 times. And then that's -2, -8. Move it down 2 times. And you might have a slight overlap a little bit. That's totally fine if that happens. Don't forget to connect your dots together. And make sure to label it g of x. Sometimes it's kind of hard to tell when it's just a vertical shift because you do end up kind of overlapping on the ends. But to double check, you should have the middle points is where you can double check them. The middle points should be 2 units away from each other. Okay? All right. So now I want you guys to try this next example. Go find this one, x minus 6 to the third power. We did do it yesterday. X minus 6 to the third power. Our A value in this case was 1. There was no stretch, compression, or reflection. Our H value was, right there's -6. Don't forget you got to switch the sign, became positive. And because it's positive, that means we go to the right 6. And then notice at the end, there's no K value, so that means K is 0, which means no vertical shift. So you guys are going to take every point and you're going to move it. So move every point to the right 6. And that's all you're going to do to that one. Okay?